Welcome to this training session. Today, our main focus is on designing the strategy for building AI and agents within your overall business solutions. Let's get started. Welcome to our training on designing an overall AI strategy, where our main focus today is on building AI and agents in business solutions. What exactly is an AI transformation strategy? It is a strategic shift that impacts your processes, people, and culture. As solution architects, your basic role is bridging the gap between high-level business strategy and the actual technical implementation. Why do we need this focus? Because AI initiatives must directly support measurable organizational objectives to deliver real value. How do we achieve this? We follow a structured framework that starts with defining business goals, moves to architecture design, and finishes with continuous monitoring. In our deep dive today, we will explore how this framework aligns with the cloud adoption framework to guide your agent lifecycle from planning to operations. Let's look at this flowchart, which represents our foundational AI transformation framework. Everything begins on the far left with defining your business goals. Once those are established, you move to formulating the AI strategy, which sets your vision and roadmap. This naturally flows into architecture design, where you figure out how to integrate AI into your existing enterprise systems. Following design is implementation, the actual building phase. Finally, the cycle completes with monitoring and optimization, ensuring your AI agents continue to meet key performance indicators and deliver value. Now that we understand the broad framework, why must we focus specifically on an agent strategy? What we are doing is introducing a dedicated operating model for planning, governing, building, and operating AI agents. The basics involve layering this agent guidance directly over the Azure Cloud Adoption Framework, or CAF. Why is this so crucial? Without a specific strategy, organizations face severe risks like agent sprawl and fragmented governance. How do we prevent this? We map the standard CAF phases, such as strategy and plan, directly to the AI agent lifecycle. In our deep dive, you will see that unifying these frameworks not only mitigates security risks, but significantly accelerates how quickly your organization realizes value from its AI investments. Take a look at this alignment diagram. On the left side, we have the traditional cloud adoption framework phases. On the right, we have the corresponding agent lifecycle phases. Notice how the CAF strategy and plan phases map directly to plan agents, where we document business outcomes and prioritize use cases. Next, the CAF ready and govern phases map to govern and secure agents, establishing our landing zones and data boundaries. Finally, the build and manage phases align with build and operate agents, where we standardize our development processes and set up telemetry. This unified model ensures consistency. Moving on to the how. How do we decide which AI technology to deploy? We start with what Microsoft calls the SaaS agent-first principle. The basics of this framework dictate that if a pre-built SaaS agent meets your functional requirements, you should use it to minimize complexity. Why do we evaluate this so carefully? Because you must balance time to market against the need for deep customization and operational costs. How do you make the choice? You assess the required scope, enterprise data requirements, and the complexity of the actions the agent must take. Let us deep dive into the options. You can extend Microsoft 365 Copilot for low-complexity productivity tasks, use Copilot Studio for low-code business process automation, or leverage Microsoft Foundry for highly complex pro-code multi-agent orchestrations. This flowchart visualizes the decision tree for selecting your agent platform. We start at the top decision node. Does a pre-built SaaS agent meet your needs? If yes, you follow the path to Microsoft 365 Copilot, delivering immediate value with minimal customization. If no, you move to the next decision. Do you need custom workflows that can be built with a low-code approach? If yes, you select Copilot Studio, which enables fast development and process transformation. If your scenario requires highly complex orchestrations, custom models, or strict compliance isolation, you follow the no path to Microsoft Foundry or custom GPU containers for a pro-code solution. Let us deep dive into architecture, specifically single versus multi-agent designs. What is a multi-agent solution? It is a system that decomposes responsibilities across specialized agents to enforce separation of concerns. The basics of this approach suggest starting with a single agent and scaling up only when necessary. Why should you use a multi-agent system? You choose this path when you must cross strict security boundaries, or when multiple teams own distinct data that benefits from decoupled agents. How is it implemented? We use explicit orchestration patterns provided by the Microsoft Agent Framework SDK rather than brittle ad hoc chaining. In our deep dive, we look at Agentic orchestration, where a central orchestrator dynamically pulls in the right expert agents at runtime, ensuring graceful degradation if one component fails. This diagram illustrates the Agentic orchestration pattern. At the top, we have the central orchestrator agent. This main agent acts as a magnet, dynamically pulling in specialized expert agents based on the runtime task requirements. Notice the delegation paths leading to the researcher, planner, and actuator agents. Each of these sub-agents has a minimal instruction set, scoped permissions, and a single clear responsibility. Once they complete their specific tasks, the dotted lines show them returning their structured metadata and results back to the orchestrator, which then synthesizes the final response. This ensures a robust, scalable architecture. A strategy is only as good as its data. What is grounding data? It is the trusted, domain-specific organizational information that an AI agent uses to formulate its responses. The basics of evaluating this data rely on 5 dimensions: accuracy, relevance, timeliness, cleanliness, and availability. Why is grounding so critical? Because supplying authoritative data at inference time is the primary way to mitigate AI inaccurate information and ensure your agents are trustworthy and auditable. How do we achieve this? We organize our data using semantic indexing and retrieval-augmented generation, or RAG, pipelines. Diving deeper, your architecture must respect data sensitivity labels and apply strict role-based access controls so that agents only retrieve and surface information that the specific user is authorized to see. This flowchart breaks down a production-ready retrieval-augmented generation, or RAG, pipeline. On the far left, we start with your raw enterprise data. This data moves into the cleaning and chunking phase, which removes noise and standardizes the format to improve precision. Next, the data is converted into embeddings and stored in a vector index, creating the semantic representations needed for grounding. When a user asks a question, the retrieval pipeline fetches the most relevant passages based on semantic match and access permissions. Finally, this retrieved context is sent to the LLM prompt assembly stage, where the model generates a grounded, highly accurate answer. Our strategy must include governance and security. What is responsible AI? It is the practice of developing and deploying AI systems in ways that are safe, trustworthy, and aligned with organizational values. The basics are built on Microsoft's core tenets: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. Why does governance matter? Effective governance manages operational risk, enforces data residency, and ensures that agents operate within legal compliance. How do we implement this? We establish strong identity foundations using managed identities, apply data loss prevention policies, and mandate publishing approvals for high-risk agents. In our deep dive, we establish strict behavior envelopes defining exactly what an agent is allowed and not allowed to do, alongside clear escalation rules for when human oversight is required. This diagram shows the layered defense-in-depth approach required for agent governance. When an agent request is initiated at the top, it first hits the identity and RBC check. This ensures the agent is operating with least privilege permissions and only accessing authorized resources. If it passes, the request moves to the data loss prevention, or DLP, layer, which prevents sensitive enterprise data from being improperly exposed or exfiltrated. Next, it flows through responsible AI filters, which block harmful, biased, or restricted prompt injections. Only when all these governance gates are successfully passed does the agent execute the action. This ensures maximum safety. Now, let's discuss Application Lifecycle Management, or ALM. What is ALM for AI? It is a disciplined approach to governing the evolution of your application code, datasets, prompts, and model configurations. The basics involve establishing a structured path from ideation to retirement. Why is ALM so critical for AI? Because AI solutions generate probabilistic outputs, and without ALM, you risk data drift, model degradation, and unpredictable behavior in production. How do we manage this? We strictly separate our environments into development, testing, and production, using rigorous promotion gates. In our deep dive, we see that moving from dev to test requires validation against golden evaluation datasets, ensuring that prompt changes or updated knowledge sources do not cause regression in your agent's performance. Here we see the recommended environment strategy for AI lifecycle management. On the left is the development environment, where you build and iterate on prompts, agent workflows, and data mappings. Before moving forward, the solution must pass Gate 1, which involves functional validation and initial safety checks. It then moves into the test environment for rigorous regression testing against realistic, anonymized data. To reach the final stage, it must pass Gate 2, which requires performance validation, cost assessment, and security compliance approval. Once approved, the agent is deployed into the production environment as an immutable, versioned artifact. Our final slide covers operations, telemetry, and ROI. What is AI operations? It is the continuous monitoring and cost-benefit analysis of your deployed agents. The basics require you to define your total cost of ownership, which includes infrastructure, data preparation, and maintenance, and compare it against your measurable business benefits. Why must we measure this continuously? Because AI models can experience drift over time, and you need hard data to optimize token consumption and articulate business value to leadership. How do you monitor this? By centralizing your logs to track latency, task success rates, and guardrail interventions. As a deep dive, solution architects use this telemetry data to perform targeted tuning, updating knowledge sources, refining prompt behaviors, and optimizing workflows to ensure the agent remains highly reliable and cost-effective. This final diagram represents the continuous improvement loop for AI agent operations. We start at the top by capturing telemetry, which includes tracking latency, error rates, and user satisfaction. This data allows us to detect anomalies and model drift. Once an issue is detected, we identify the root cause, whether it is a knowledge gap, a prompt misinterpretation, or a connector failure. We then implement tuning, which could mean updating a document or adjusting a system prompt. Finally, we validate and release the update through our ALM pipeline, returning to the monitoring phase to ensure our AI strategy delivers reliable, long-term success.